Hi everyone, this is Whip Bachnight from Brainstem Tutoring, and in this video we're going to go over another Lewis dot structure of something that would need or require an expanded octet, something that is a little less familiar with most students. But like every Lewis dot structure, we're going to start off with the same process. Number one, some valence electrons. Iodine has 7. Chlorine has 7, but there's 2 of them. And this negative charge means there's an extra electron. Don't let that fool you. Negative charges mean there's extra electrons. Positive charges means there's missing electrons. This extra electron doesn't necessarily belong to one of the chlorines. It could belong to any of the atoms. So don't assume that because the negative is next to the Cl that it has to be on the Cl either. All right, so that's a total of 22 valence electrons. Number 2, skeleton structure. Iodine is I think the more obvious choice to be in the middle because there's one of them. All right, step number 3, octet rules. Now the normal octet rule says we need to add these electrons to make everybody happy, right? And I've been kind of slack because I'm trying to go quickly. Of our original 22 electrons, let me move that over, we used up 4 of them for bonds. We just used up 6 plus 6 plus 4, which is 16 electrons, to have 2 electrons left. Now here's the thing. We have all of our full octets, right? Octet meaning 8. However, there are some exceptions to the octet rule. Now, so we're getting to step 4, Goldilocks logic. Either we have the right amount, too few electrons to make everybody happy, or too many. In this case, we have too many electrons when comparing to the octet rule. But remember the exceptions to the octet rule. What I want my students to know is that hydrogen is cool with 2 electrons or 1 bond. Pretty rare, but beryllium, it's a metal, but sometimes it's, ionic bonds, covalent bonds are a spectrum, so there really is no black and white. Sometimes beryllium can be in a molecule or Lewis dot structure. If it is, it just wants 4 valence electrons. On any test, I imagine a professor will put boron because it's such a unique thing. Boron just like 6. But here's the kicker. When something is a central atom in a skeleton structure and it's on the 3rd row or below on the periodic table, you can have 8 or more electrons. Well, what is happening with our central atom? Iodine is in the center, and it's, I believe, on the 3rd row of the periodic table. I know it's on the 3rd row or below. So therefore, it is allowed to have extra electrons. So we're going to stockpile the extra electrons on the middle. And the 2 rules are being obeyed by Lewis dot structures. Number 1, it has the right number of valence electrons. And 2, the octet rule is being obeyed because iodine is one of the exceptions. One of the most common mistakes I see when it comes to cases where it's appropriate to have an expanded octet, folks usually like to try to add bonds, and that's the opposite of what we need. Adding bonds is being more thrifty or frugal with our bonds. We're making them share more. When you have too much of one resource, you don't need to be thrifty and make people share more. You just stockpile that extra resource somewhere where you can store it, like the center atom. Wonderful. Be careful about expanded octets, and I hope this video helps. If you have any questions, leave a comment or email us, and good luck studying.